Welcome to Lesson 4-5 on finding in and working with equivalent fractions. Today's goals, students will be able to find and prove that two fractions are equal. Students will be able to put fractions in simplest form, and students will be able to add the missing part that makes two fractions equal. Now, if you're in class with me, we will be doing a lab with this and exploring this a little bit further together. But here's a quick introduction. All right, so this first page, I would like you to just do this on the front of your notes page. So every problem that I do, I would like you to do with me on that notes page. All right, so equivalent fractions are fractions that have the same value. They are equal. So for example, in this first picture, if you have 3/5 of a candy bar and I get 6/10 of a candy bar, we in fact are eating the same amount of candy bar. So you can see that this one was divided into 5 equal parts. Our denominator tells us how many parts a whole is split into. And then you can see that the numerator, the top number, tells us how many pieces we have. So again, in the fraction 3/5, this is the numerator. This is the denominator. And again, the denominator tells me the number of pieces that the whole is cut into. And then the numerator is the number of pieces I have. If I'm saying that I have 3/5. All right, so with 6/10, this candy bar was cut into more pieces and I got more of them. But just because I got more pieces doesn't mean I have more candy because the pieces, of course, are smaller. So you can see that the larger our denominator is, the more pieces I cut something into, the smaller those pieces are going to be. So if we had to decide what was greater, 1/5 or 1/10, now generally we say, well, 10 is larger than 5. But when we're talking about fractions, and I want a piece of that candy bar, would I rather have 1 out of 5 pieces or 1 out of 10? Well, I can see right on this picture that I would rather have 1 out of 5, because if it's cut into less pieces, then each one will be larger. So 1/5 is larger than 1/10. We'll learn more about that later. All right, so let's go ahead and find some equal fractions and see if we notice a pattern and a way to find this without drawing a picture. So here we have some fraction bars. We'll just call them candy bars. And you can see that the same amount of candy bar is shaded for every single one. But we call those fractions different things. So our first fraction bar right here, I'm going to call this 1/2. I cut it into 2 equal pieces and I have one of them. Okay, candy bar number 2 we cut into 4 equal pieces. And to have the same as 1/2, I have to have 2 of them. So here I have 1/2. Here I have 1/2 pieces that are fourths. So 1/2 is the same as 2/4. Now in this third example, I cut my candy bar into 6 equal pieces. And if I want to have the same as 1/2, I am going to have 3 of them, or 3/6. So 1/2 is equal to 2/4 is equal to 3/6. In example number 4, I cut them into 8 pieces. In order to have half the candy bar, I would have 4 out of the 8 pieces. So you can see from the picture that these 4 fractions are equal to each other. All right, let's take a look at example number 2. 2/3, so I have, again, 3 equal candy bars. The first one is cut into 3 equal pieces, and I have 2 of them. So my denominator is thirds, and I have 2 of those thirds. In the second candy bar, you can see it's exactly the same amount. This time I cut it into sixths. So I have 6 pieces, and in order to have the same as 2/3, you can see that I have 4 of the 6. This last example, we cut our candy bar into 12 pieces, and I have 1, 2, 3, 4, 5, 6, 7, 8 of the 12ths. Now we can visually see that these are all equal, But again, I don't want to draw a picture every single time I want to find an equal fraction. So using this example, let's see if we can find a rule or a pattern that's going to help us out. Well, when I went from 2/3 to 4/6, I cut each of the thirds in half like this. And that gave us 6. So I doubled the number of pieces my candy bar was cut into. So let's go ahead over here and write 3 times 2, and that's equal to 6. So again, I doubled the number of pieces my candy bar had. Well, when I doubled the number of pieces it had, notice that I also doubled how many that I had shaded. So my 2/3 became 4/6. So we doubled the 3, the denominator, but we also need to double the top. All right, again, if I start with this first example in thirds, to get to 12ths, I cut each of my thirds into 3 equal pieces. Actually, I'm sorry, we cut it into 4 equal pieces. So it was cut in half, like we had for the 6th, and then we cut those in half, the 6th in half, and or here we can cut these 6 in half again, and let's see what happens. Well, I just doubled the number of pieces, so 6 times 2, we now have 12 pieces, but I also doubled the number of pieces that I had shaded. All right, if we go back to this example, and if I want to look at how do I get from 1/2 to 4/8, now we see from the picture that they're equal. But notice that again, how do I get from 2 to 8? Well, that's times 4. And how do I get from 1 to 4? That's times 4 as well. So what I'm hoping you see is the rule here, that if I want to have equal fractions, or if I want to see if two fractions are equal, the rule is whatever you multiply the denominator by, you multiply the numerator by. Or vice versa, whatever you multiply the numerator by, you also multiply the denominator by. Now this also works for division. If I want to take my 8/12 over here and change that to back to 2/3, I know that they're equal, but let's see what happens. How do I get from 8 to 2? I divide by 4. How about 12 to 3? Divide by 4. So it also works to divide the top and bottom by the same. Now, just to be really clear, this does not work by adding or subtracting something to the numerator and denominator. You will see that if I take 1/2, if I add 2 and add 2, that gives me 3/4. But is 1/2 equal to 3/4? Hopefully you would know that no, it absolutely is not. 1/2 is equal to 2/4. So please remember that you may not add or subtract to make equal fractions. You may, however, multiply the top and bottom by the same number or divide the top and bottom by the same number. Either of those are going to work. All right, so let's take a look at this next page, and we're going to explore a couple different concepts. So I'm going to do one of each with you, and then you're going to do the rest on your own. So find fractions that are equal to 3/6. So the first thing you need to do for this example is cut this into 6 equal parts, and then shade 3 of them. All right, so we can see that this is how much, and you're going to want to really be careful with your picture, because you can see I'm just a little bit off here, and that's going to cause some problems. So 3/6 you can also see is equal to 1/2, or let's prove it, divide by 3, and you can see that works. And then how about I cut this into 4? Again, 2 of those is still equal to 1/2 and 3/6, and now I have 2/4. Let's prove it, times 2 times 2. And sure enough, that works. So go ahead and try shading 1/4, and then see if you can find two other fractions that are equal, and then just double check your work by seeing if you can multiply the top and bottom by the same number. All right, I'm going to do the first one here with you. I want to make these two fractions equal and determine what my numerator is. So what I'm going to do is ask myself, how do I get from 7 to 35? Well, that's going to be times 5. So then if I multiply the bottom times 5, I know I have to multiply the top by 5 as well. So 3 times 5 is 15. So 3/7 is equal to 15/35. I'll do one more with you because this is division. So 6 to 1, I'm going to divide by 6. So that means I have to divide the bottom by 6, and 48 divided by 6 is 8. So I'll go ahead and try those next two. Then when I want to do simplest form means that I divide the top and bottom by the greatest common factor, and I have an equal fraction where the top and bottom no longer have any common factors. So the easiest way to do this is if you can find that greatest common factor right away. So what is the largest number that goes into 10 and 15? Well, I'm going to say 5. So if I divide the top and bottom by 5, I end up with 2/3. 10/15 is equivalent or equal to 2/3. All right, greatest common factor of 2 and 8 would be 2. 2 goes into 2 and 2 goes into 8. So if I divide the top and bottom by 2, I'm going to end up with 1/4. And 2/8 is going to be the same amount as 1/4. So you go ahead and try those last two. Pause the video and then you can see if you're right. All right, so you can go ahead and look this over and see if it looks right. There are, other answers for this, but this would be probably the most common. And if you don't find the greatest common factor right away, just a little FYI, let's say for 12/16 down here, I had first divided by 2 and gotten 6/8, then what I need you to recognize is that 6/8 is not simplified yet. I can still divide both of those by a common factor. So I would need to go ahead and divide by 2 again until you see the simplest form. This is simplest form because I can't divide 3 and 4 again by the same number. 1/10 is simplest form because 1 and 10 can't be divided any longer by any common factors. So if you don't get it simplified all the way the first time, simply divide again until you see you have that simplest form. All right, good luck with the rest of the lesson.